Module 10, Cybersecurity Careers and Certifications. Career paths in cybersecurity. SOC Analyst, Pen Tester, Threat Hunter, Cloud Security Engineer. Imagine this. It's 2:13 a.m. A global company's network is quiet, almost too quiet. Suddenly, a single alert pops up, a strange login attempt from a country where the company has no employees. Within seconds, that alert multiplies into dozens. A silent digital storm is forming, but before the attacker can take one more step, a cybersecurity professional sitting in a dimly lit SOC room leans forward, cracks their knuckles, and says, "Not tonight." This is the world you're about to enter, a world where every click matters, every log tells a story, and every decision can save millions. Welcome to Module 10, Cybersecurity Careers and Certifications, where we break down the real jobs, real skills, real tools, and real pathways that build the defenders of the digital world. Introduction: Why cybersecurity careers matter today. Cybersecurity is no longer a niche field. It's the backbone of every modern business, every government, every financial institution, every cloud platform, and every digital interaction you make. Every time you shop online, stream a movie, send a message, or upload a file, someone, somewhere, is working behind the scenes to keep that experience safe. Cybersecurity careers are exploding globally because cyber attacks are increasing in frequency and sophistication. Companies are losing billions due to breaches. Cloud adoption is skyrocketing. AI is creating new attack surfaces. Every industry, from healthcare to banking to manufacturing, needs security professionals. But here's the truth most people don't know. Cybersecurity is not one job. It's an entire universe of career paths. And today, we're diving deep into 4 of the most powerful, high-impact, and future-proof roles: SOC Analyst, Penetration Tester, Threat Hunter, Cloud Security Engineer. Each role has its own mindset, tools, responsibilities, certifications, and growth path. By the end of this video, you'll know exactly what each role does, what skills you need, what tools you must learn, what certifications matter, what mistakes to avoid, how companies hire, how you can start today. Let's begin. Section 1. SOC Analyst, Security Operations Center Analyst. What is a SOC Analyst? Think of a SOC analyst as the digital firefighter of an organization. They sit inside the Security Operations Center, a room filled with screens, dashboards, alerts, and live threat feeds. And their job is simple: detect threats, analyze threats, respond to threats, stop threats. If cybersecurity were a hospital, SOC analysts would be the emergency room doctors, the first responders who stabilize the situation before specialists take over. Let's say a company employee receives a phishing email. They click it. A malicious script runs silently. The attacker gains initial access. Before the attacker can move deeper, the SOC analyst sees a suspicious login, a strange IP address, a sudden spike in network traffic. The SOC analyst investigates. Who clicked the link? What did the script do? Did it create persistence? Did it escalate privileges? Did it communicate with a command and control server? Then they respond. Isolate the machine, block the IP, kill the process, remove the malware, reset credentials, update firewall rules, and notify the incident response team. This is SOC life: fast, intense, and incredibly rewarding. SOC analysts rely on tools that act like CCTV cameras for digital systems. SIEM, Security Information and Event Management, is the SOC's main dashboard. It collects logs from everywhere: servers, firewalls, endpoints, cloud, applications, and shows alerts. Examples: Splunk, IBM QRadar, Microsoft Sentinel, Elastic SEIM, ArcSight. Think of SEIM as a giant detective board where all clues come together. EDR, Endpoint Detection and Response Tools, watch what happens on laptops and servers. Examples: CrowdStrike, SentinelOne, Microsoft Defender for Endpoint, CyberReason. EDR is like having a security guard on every device. SOAR, Security Orchestration, Automation, and Response, automates repetitive tasks. Examples: Palo Alto Cortex XSOAR, Splunk SOAR. SOAR is like having a robot assistant that handles routine alerts. Skills you need to become a SOC analyst: understanding logs, Windows, Linux, network logs, basic networking, TCP/IP, ports, protocols, malware behavior, phishing analysis, incident response fundamentals, SIEM dashboards, analytical thinking, pattern recognition, and ability to stay calm under pressure. Common mistakes beginners make. Mistake 1. Treating every alert as a crisis. Not every alert is an attack. Some are false positives. Some are harmless. Learning to prioritize is key. Mistake 2. Ignoring context. A login attempt from another country might be normal if the employee is traveling. Context matters. Mistake 3. Relying only on tools. Tools help, but human judgment is irreplaceable. Best practices for SOC analysts. Always correlate multiple logs before concluding. Document everything. Follow incident response playbooks. Keep learning new attack techniques. Communicate clearly with other teams. Stay updated with threat intelligence feeds. Certifications for SOC analysts. CompTIA Security Plus, EC Council CEH for understanding attacks, Splunk Core User and Power User, Microsoft SC200 Security Operations Analyst, Blue Team Level 1, BTL1, Google Cybersecurity Certificate. Career Growth Path: SOC Analyst, Senior SOC Analyst, Incident Responder, Threat Hunter, SOC Manager, Security Architect. Section 2. Penetration Tester, Ethical Hacker. What is a pen tester? Pen testers are the ethical hackers of the cybersecurity world. Their job is to break into systems legally to find weaknesses before real attackers do. If SOC analysts are firefighters, pen testers are the fire inspectors who check the building for vulnerabilities. What does a pen tester actually do? Real-world explanation. Imagine a bank hires a pen tester. The pen tester's mission: try to hack the bank's website, try to break into their network, try to bypass their firewalls, try to exploit their employees, try to steal data, try to escalate privileges, try to reach the crown jewels. They use the same techniques real hackers use: reconnaissance, scanning, exploitation, privilege escalation, lateral movement, data exfiltration. But instead of stealing money, they write a report explaining what they found, how they exploited it, how dangerous it is, how to fix it. Tools pen testers use. Explain simply. Kali Linux, the Swiss Army knife of ethical hacking. Nmap, used for scanning networks. Think of it as a radar that shows open doors. Burp Suite, used for web application testing. It intercepts traffic so you can manipulate it. Metasploit, a framework for exploiting vulnerabilities. Wireshark, a network packet analyzer, like reading the DNA of network traffic. Bloodhound, used for Active Directory privilege escalation mapping. Hydra, John the Ripper, password cracking tools. Skills you need to become a pen tester: strong networking knowledge, Linux fundamentals, scripting, Python, Bash, web application security, OWASP Top 10, vulnerability scanning, exploit development basics, report writing. Common mistakes beginners make. Mistake 1. Focusing only on tools. Tools help, but understanding vulnerabilities is more important. Mistake 2. Not documenting steps. If you can't explain how you hacked something, the test is useless. Mistake 3. Ignoring scope. Pen testers must never test systems outside the agreed scope. Best practices for pen testers. Always get written permission. Follow a structured methodology, PTES, OWASP. Keep detailed notes. Validate vulnerabilities manually. Provide clear remediation steps. Stay updated with new exploits. Certifications for pen testers. CEH, Certified Ethical Hacker. EJPT, Junior Penetration Tester. OSCP, Offensive Security Certified Professional, PNPT, Practical Network Penetration Tester, CompTIA Pentest Plus. Career Growth Path, Pen Tester, Senior Pen Tester, Red Team Specialist, Exploit Developer, Offensive Security Lead. Section 3, Threat Hunter. What is a threat hunter? Threat hunters are the detectives of cybersecurity. They don't wait for alerts. They proactively search for hidden attackers inside the network. If SOC analysts respond to alarms, threat hunters look for threats that produce no alarms at all.
Imagine an attacker has already bypassed the firewall. They're inside the network. They're moving slowly, quietly, avoiding detection. Threat hunters look for unusual patterns, rare processes, strange network connections, suspicious user behavior, hidden persistence mechanisms, indicators of compromise, IRCs, tactics, techniques, and procedures, TTPs. They use threat intelligence to predict what attackers might do next. Threat hunting is like searching for a needle in a haystack, except the needle is invisible. Tools threat hunters use: SEIM, EDR, XDR. They combine multiple tools to see the full picture. MITRE Attack Framework is a global database of attacker behaviors. Velociraptor is for digital forensics and endpoint analysis. Yara rules are used to detect malware patterns. Threat intelligence platforms include MISP, Recorded Future, and Anomaly. These platforms help threat hunters aggregate and analyze intelligence to stay ahead of attackers. Skills you need to become a threat hunter: deep understanding of attacker behavior, knowledge of malware techniques, log analysis mastery, ability to create hypotheses, strong scripting skills, understanding of MITRE attack, and ability to think like a hacker. Common mistakes beginners make. Mistake 1. Hunting without a hypothesis. Threat hunting must be structured. Mistake 2. Overlooking small anomalies. Attackers hide in tiny details. Mistake 3. Not validating findings. False positives waste time. Best practices for threat hunters. Use MITRE attack to guide hunts. Combine multiple data sources. Document hunting procedures. Share findings with SOC and IR teams, and continuously refine hunting techniques. Certifications for threat hunters include CompTIA CISA Plus, GIAC Cyber Threat Intelligence, GCTI, MITRE Attack Defender, and Blue Team Level 2. Career growth path: threat hunter to senior threat hunter, to digital forensics expert, to incident response lead, to security architect. What is a cloud security engineer? Cloud security engineers protect systems hosted on cloud platforms like AWS, Azure, and Google Cloud. They ensure that cloud environments are secure, compliant, and resilient. If cybersecurity were a city, cloud security engineers would be the architects designing secure skyscrapers. What does a cloud security engineer actually do? Imagine a company moves all its data to AWS. The cloud security engineer must secure identity and access, configure firewalls, encrypt data, monitor cloud logs, prevent misconfigurations, set up secure networks, implement zero trust, ensure compliance, and respond to cloud incidents. Cloud misconfigurations are one of the biggest causes of breaches today. Tools cloud security engineers use: cloud-native tools, AWS, IAM, CloudTrail, GuardDuty, Security Hub, KMS, WAF, Azure, Azure AD, Defender for Cloud, Sentinel, Key Vault, NSG, GCP, Cloud IAM, Cloud Armor, Chronicle, Security Command Center. Infrastructure as code tools include Terraform and CloudFormation for building and securing cloud environments efficiently.
Container security tools include some of the most popular solutions such as Aqua Security, Prisma Cloud, and Sysdig. These are essential tools used by professionals to protect containerized applications and manage security risks in cloud environments. Skills you need to become a cloud security engineer include understanding cloud architecture, identity and access management, network security, encryption, logging and monitoring, DevSecOps, containers and Kubernetes, as well as applying zero-trust principles across cloud environments. Common mistakes beginners make. Mistake 1 is leaving cloud storage public, which has led to massive data leaks. Mistake 2 is weak IAM policies, allowing attackers to escalate privileges. Mistake 3 is ignoring the shared responsibility model between cloud providers and users. Best practices for cloud security engineers: enforce least privilege, use MFA everywhere, encrypt data at rest and in transit, monitor logs continuously, use infrastructure as code, automate security checks, and regularly audit cloud resources to ensure maximum protection. Certifications for cloud security engineers include AWS Security Specialty, Azure Security Engineer AZ500, Google Professional Cloud Security Engineer, CCSP, Certified Cloud Security Professional, and HashiCorp Terraform Associate. These credentials validate expertise and boost job prospects in the field. The career growth path for cloud security engineers starts with Cloud Security Engineer, advances to Senior Cloud Security Engineer, then Cloud Architect, followed by DevSecOps Lead, and ultimately becomes CISO, the Chief Information Security Officer, overseeing comprehensive cybersecurity. Choosing a cybersecurity career is like picking a character in a video game. Each role has its own strengths, weaknesses, and unique playstyle. Matching your interests to these roles helps you find the ideal job in a fast-changing cybersecurity world. If you enjoy fast-paced environments, the SOC Analyst role might suit you for quickly solving puzzles and responding to threats. If you like hacking and breaking things, Pen Tester is ideal. Deep investigation fits threat hunters, and building secure systems is for cloud security engineers. Actionable steps to start your cybersecurity career today. Step 1. Learn the basics such as networking, Linux, and security fundamentals. Step 2. Choose your path among SOC, pen testing, threat hunting, or cloud. Step 3. Build skills through hands-on labs, projects, and simulations. Step 4. Get certified by choosing the right certifications for your chosen path. Step 5. Build a portfolio to showcase your skills on GitHub or LinkedIn. Step 6. Apply for internships or entry-level roles, with SOC Analyst often being the easiest entry point. Step 7. Keep learning. Remember, cybersecurity evolves daily, so continuous education and staying updated on new technologies and threats are crucial for long-term success in this dynamic and ever-changing field. Cybersecurity is not just a job, it's a mission, a responsibility, a calling. Whether you become a SOC analyst fighting real-time threats, a pen tester breaking into systems ethically, a threat hunter uncovering hidden attackers, or a cloud security engineer securing the future of digital infrastructure, you are stepping into a world where your skills protect millions. Every alert you analyze, every vulnerability you fix, every threat you hunt, every cloud resource you secure, it all contributes to a safer digital world. And the best part? Cybersecurity is a field where passion beats degrees, skills beat titles, and curiosity beats experience. If you're willing to learn, practice, and grow, the industry will welcome you with open arms. If this video helped you understand cybersecurity careers, then imagine what you can achieve by mastering them. Subscribe to Knowitrix for more deep dive modules, cinematic explanations, real-world case studies, and step-by-step cybersecurity learning paths. Your cybersecurity journey starts now, and Knowitrix will guide you every step of the way.